Whenever he says the word actual, he's interpreting everything that's going to be actually happening with respect to the inertial frame. Does that help a little bit? Or I'm sure you already knew this, but
Well, that's right. So in Newtonian physics, the mass is accelerating with respect to inertial frames. In the current theory of gravity, the one that we've had for 100 years, it's not. Mass is an inertial frame. A freely falling object is an inertial frame.
Okay, so in the current understanding of gravity, mass is not, when you drop the mass, it's not accelerating. And
Depends on your reference frame.
And the ground is accelerating. So the ground must be accelerating because we have two objects getting closer together at an accelerated rate. So which one of them is accelerating towards the other object?
If you put an accelerometer on the ground, it will tell you its acceleration.
So the ground, you're saying the ground, why can't I just get a clear answer? You're saying the ground
An accelerometer will tell you, an accelerometer will tell you that the ground is accelerating upward at 9.8 meters per second squared. Now, you can interpret that any way you want, but that's what an accelerometer, a device that measures acceleration, will tell you.
How's
okay,
that
cool. But now there's a huge problem. Now there's a huge problem here, though. If you're saying we drop something, that item doesn't move. It's actually the ground accelerating up to meet the object. You realize that the conundrum you're going to be in if you think Earth is a globe with this one, right?
No, I understand the conundrum that you feel like it raises, but that's just because you don't understand general relativity.
Well, I understand how a ball works, and in order for the ground to accelerate up and the object not accelerate down, you would have to have a larger growing ball.
Nope, not in general relativity. You don't.
No, in reality, you would have to. There's
No,
no way
Jeremy.
for that to happen. There's no way for that to happen without the ball getting bigger. You have the ground on one side going up to meet the person, and you have the ground on the other side simultaneously going up to meet the person. There has to be a larger size ball.
Remember we talked about velocity, Jeremy? There's a change of magnitude. There's also a change of direction.
Zanuck, please, man.
Please, you don't want me to get involved? Okay, go ahead.
This is what I call proof by bold assertion. You claim that my position would require the Earth to grow in size. It doesn't. And the only reason you think it does is because you don't understand the current theory of gravity that has held for 100 years.
I do understand the current theory of gravity, and I also understand how balls work. And in order for you to drop something and that item not move and the ground actually accelerate up to the ball, that means if you were to do that antipodal, the ground would be going up towards both of the objects at the same time simultaneously, correct?
This is proof by bold assertion, not correct.
Can I just get an answer on the thing
No,
I just asked?
not,
if you drop
not
something,
correct.
If two people drop okay, well then explain to me what happens when two people drop something antipode to each other, how the ground can accelerate up in both instances simultaneously, and you don't get a bigger ball.
Do you want your explanation in terms of Newtonian theory or in terms of Einsteinian theory?
How about reality? Does physics deal with?
We don't know what reality is. We only know what reality does. And one thing we know for sure is that when you measure the acceleration of the ground using an instrument that measures acceleration, the ground is accelerating upward at 9.8 meters per second squared.
Okay, you keep saying we don't know what reality is. I find that awkward for a physicist to be saying. And you say we know what reality does.
We know
and that's
what we do.
Specifically what I'm asking you right now is what reality does. What does reality do? You have the ground going up. Hold on, man. Hold on a second.
Yep.
You got the ground going up. Antipodal.
I didn't say the ground was going up. I didn't say that the ground is going up. Sorry, I'm sorry. I just, when he says something I didn't say, I feel like I need to correct it.
I know we all feel that, and it leads to a lot of interruptions. I hear you.
I know you're right. You're right. I'll try. I will. My bad. I'll try to do better.
Well, as long as like, okay, like we'll just mod for Jeremy and John to go back and forth. So therefore you don't, no one else is going to clip in. Cause I know sometimes like if someone says something, you might feel like I have to interrupt because you don't want someone else to come in and then they go on some 45-second thing. And so if we can, just for right now, if just John and Jeremy can go back and forth. So you guys know that you'll be able to, you'll be able to respond. So
thanks, Gio. You are a good moderator. I appreciate that.
thanks.
Okay, so if the ground's not accelerating up, which object is accelerating? Because we definitely have two objects, the ground and the object we drop, getting closer together at an accelerated rate. Which object is the one accelerating? One of them has to be accelerating. Would you agree?
No, not really. But if you make me choose, I'll choose the ground.
Well, how would you have two objects accelerating closer to each other without one of the objects accelerating?
Acceleration in relativity can only be measured locally, and it's always measured, like in Newtonian physics, with respect to inertial reference frames. The difference is that in relativity, inertial reference frames are freely falling reference frames. In Newtonian physics, it's kind of hard to define an inertial reference frame, but it's supposed to be something that isn't accelerating, which is kind of weird. It's a kind of a circular reference.
Yeah, it's not weird or hard. It's literally physically impossible. You have two objects getting closer together at an accelerated rate. One of the objects has to be actually moving towards the other one, accelerating. You're telling me you don't know which object that is?
Yeah, that's right. That's what I'm telling you.
Well, that's what I said when I came out with my statement to Jesse about these guys don't know anything. You don't know. What do you know?
The problem is, well, what I do know is what general relativity, how it describes things. Now, I also know how to interpret those descriptions in terms of everyday life. If you want me to give you what it looks like is happening, I'm happy to say it looks like the ball is accelerating toward the ground and not vice versa. But that's not what our current theory of general relativity, which has held sway for over a century now. That's not what it says.
Yeah, but it says something ridiculous like the ground's accelerating up, but then you didn't say the ground's moving up. So you have to have one of the objects moving. One of the objects has to be accelerating. They're getting closer together at an accelerated rate. You don't have either of the objects moving in GR?
I didn't say that either. One thing I can say for sure, that's true in both Newtonian and Einsteinian physics, is that when you drop something, the distance between it and the ground gets smaller at an increasing rate.
Yeah, in GR, which object is moving, the ground or the thing you drop?
In GR, you can adopt any reference frame you want. It has no meaning to say which object is moving. There is a meaning to which object is accelerating, and in general relativity, it's the ground that's accelerating. But that doesn't mean that I'm so stupid that I don't understand what things look like, and I can interpret things for you in terms of Newtonian physics just as well as I can in Einsteinian. I know you don't like the Einsteinian picture. That's fine. Don't use it.
Dude, don't do that.
I'm just telling you.
Don't start telling me what I like.
Well, it seems to me like you don't like the idea of the ground accelerating, and I understand why that doesn't make sense to people. So I'm happy with that.
It makes sense. It makes sense. Please don't tell me what I like or don't like. That's don't divine my thoughts. However, you're telling me that in general relativity, we drop an object, the object doesn't move, it's the ground accelerating up. That's the position?
Moving is another thing. I mean, just to be clear, we're talking about acceleration. You can't measure velocity. There's no such thing as absolute velocity. There's no velocity meter that doesn't refer to something else. But accelerometers don't need that. An accelerometer you can carry with you. It doesn't need to refer to anything else. It can tell you all by itself what your acceleration is.
Well, it's
okay,
a 0 point.
the stance that general relativity holds is you're accelerating without moving. It's absolutely ridiculous. When we drop something, it's a physical impossibility for the ground to move up and the sphere and the ball not get bigger if you're antipodal. Obviously, that's just basic physics on how a ball works. So we know that if the Earth's not getting bigger and you're on a globe with a 3959 radius, that the objects have to be accelerating towards the center, and that is the mass that's accelerating, not the ground accelerating up.
This is
It's
called
basic,
proof by bold
very
assertion.
very
Jeremy,
simple physics how a ball would work.
Jeremy, you're really pigeonholing him into thinking acceleration is a change of velocity, which is really what you're saying is a change of speed, this change of distance with respect to time. Acceleration is more than that. It's a change of velocity, which means not only is it a change of the magnitude, it could be the change of the direction. And what he specifically said earlier is general relativity's talk about a direction change. The curving of space-time is allowing this ball to run into the Earth, which has got in its way. That's why it's falling down and the Earth is not getting larger, because can I just finish that one?
Because the ball's the thing actually moving. That's why.
Well, it's moving
not
down.
It's not the sphere getting bigger, because if it wasn't the ball accelerating, the Earth would have to be accelerating up, and you would have to get a bigger ball.
You missed
just
it.
by being on a ball, you have to know that the mass is accelerating downwards.
You missed it. It's moving through time. Everything moves through time, right? We're all going through time, but space as well. So time and space get bent. And now this ball this inertial, that's not really moving, not doing anything, it's got no forces acting on it. The ground gets in its way because time and space has been bent. So now it hits it. It hits it.
All these words that you're using, they're not.
No. Why do you have to interrupt me when I'm in the middle of a sentence? Because it just makes the point more obfuscated. Jeremy, it's not a change of speed, it's a change of velocity. It's different because we have a direction change, not the speed change. So we just had something get into the way of the ball, if you can think of it that way. Something got in the way, like centrifugal force, same type of inertial force. The door gets in your way. You should be going straight, but the car's curving. The door gets in your way and stops you. Fake force.
Gee, are you still here? Like, can we get a hold of this obvious person?
I think John will back it up. John, is that kind of a good way of explaining it in layman's terms?
Yeah, I mean, everything you said is true. The whole change of direction thing is not really relevant to the dropping ball, but it's kind of similar in a way that if you talk about fore velocity, which is what you talk about in relativity, where time is one of the dimensions, you're absolutely right that the thing that's hard for lay people to appreciate, to understand, is what it means when we say space-time curves. That's really, I try not to ever go there. I just try to stick with simple concepts like the fact that free-falling objects are inertial objects. It's the general relativity is beautiful because unlike Newtonian physics, it's easy to know what an inertial frame is. An inertial frame is something that has no force acting on it, and gravity is not a force. A lot of people should like that, right? In relativity, gravity's not a force.
Right.
It's just the curving of space-time that makes inertial motion look like acceleration to us.
But the ground hitting.
Oh my God.
Hitting. I just wanted
I stopped when you were talking earlier, and you're still.
Well, no, he was talking kind of to me. And I was asking. I appreciate his perspective. He's the one that's probably most educated in the field rather than all of us. I have a general understanding, but so I'm trying to explain it in layman terms so that, not that I can go any farther than layman's terms at this point in my career in life, but the fact that the ground is not moving upward. So I thought if we start analogizing this to what velocity really is, a change of magnitude or a change of direction, maybe it makes more sense for this Earth to get in its way of the path of it moving through space-time, and that way it hits it. The hitting of the ball to the ground is an inertial force, but the ground acting on the ball is a proper force. And so that way everyone's happy, and it becomes more of this magical type of understanding of gravity, which may or may not be accepted by this community, but at least it gives the explanation of what general relativity does.
The problem is,
I think you're right. I mean,
can I say something?
Yeah, hold on, guys. Let Arul get in. He's been waiting.
Holy shit, man.
I wanted to response to that, but go ahead.
So the problem is there's a complete language differential when you guys talk about relativity versus just actual reality, because what you're saying when the words motion, time, space all take on a completely new meaning. And it's actually what you believe is happening in reality is not something that is visualizable
Motion
whatsoever.
times speed? What'd you
You-
say? Motion times speed?
I'm saying motion, space, and time
Okay.
means something completely different in relativity.
Well, it's not that different.
Let me finish. Either special or general, as opposed to in actual reality. The worldview that you guys put forward actually is not something that is visualizable. Keyword visualizable. It is something that could only be represented in abstract mathematics and not represented in the standard reality concepts of space, time, and motion.
Well, that's just not true. I can take the mathematics of general relativity, and I can interpret those results in terms that you'll understand, right? If you want to say, what does it look like the ball is doing from my standpoint? Now, I can go into general relativity. I can notice that there is a force making me accelerate relative to inertial frames, like the ball, which is falling. And then I can remember that most of my friends on Earth feel like when the Earth is pushing on them, they're just standing still. And so, okay, so what general relativity says is that you are going to see that ball accelerating toward the Earth. And that's perfectly understandable, and that's what general relativity says.
You missed my point completely. Can you actually try and steelman what I said?
Well, one thing you said is that the concepts of velocity and et cetera are completely different in general relativity. That's just not true. So I could steelman that's what you said.
Yes,
it's not true.
You didn't get the whole point, but you did mention one thing, and I didn't say velocity. I said speed, but sure, same thing. It does not mean the same thing as it means in actual reality, and it is not visualizable. What you believe is happening in reality is not visualizable. What's happening in reality, because that's why you ran into the problem with Jeremy when he brought up the antipodal issue. When you think in reality, the best description is that the ground is accelerating upwards. If it were visualizable, that would lead to the ball growing. But it's not. What you believe is happening in reality is not visualizable. What you believe is happening in reality is not visualizable. I'm not saying you can't then say, well, according to this theory, this is what you would see. No, that's fine, right? Remember, there's two key distinctions here. I'm not saying that what you say in reality, you could not translate into some sort of visual picture that we could then observe. I'm saying what you actually believe is happening in reality, with what space and time actually mean, what motion actually means, is not something that's visualizable.
Okay. If you say so, but I mean, ask me a question about what general relativity predicts you will see happen, and I can tell you in terms that you'll understand.
Can I ask Dr. John a question? What are the properties of space, John?
Well, okay, so whenever I get a question like this, I have to start with, once again, I can only answer in terms of what the properties of space are in a theory. Theories are models, they're toy models, they're not reality.
Well,
we don't know what space is the truth of the matter. And now you'll make fun of me for that, but it's true. We only know and we can only try to predict things that happen. In physics, we've done a really good job at getting to the point where we can tell you in precise detail, most of the time, exactly what is going to happen. And we can tell you why it happens in our toy model, but we don't know if that's why it happens in reality. We just know that it does happen in reality.
Well, it seems like the current science you're appealing to, bases their assertions on descriptions, like everything's a description rather than an actual logical explanation. And I don't think space is an is rather than it isn't, being a privation of matter. So how do you materialize physicality into something non-physical, such as space? Like, how could you ever get a bent space when space isn't a thing rather than the
Yeah,
absence of
I
a thing.
agree. That's a great. I mean, what you just said is really good. When you ask me, is space-time curved? I can answer that two ways. I can answer it one way. I can say, yes, it absolutely is in the theory of relativity. But I could also say, I don't know. In reality, I don't know. I mean, I don't even know if there is space and time. All I can tell you, and I can tell you very accurately, is what will happen if you set some things up and you push the go button. And nobody can ask for more than that. If I can tell you what will happen under any circumstances, you can't ask for more than that, because if you say no, I want to know what the reality really is. I don't know what reality really is. I just know what it does.
And here's
Well,
one more question.
I mean, I appreciate the honesty and the fact that you're alluding to the appeal to a theoretical model rather than actual logical reality and getting to an explanation. So I don't know. It'd be nice if science really actually got to explaining things rather than just doing these vague, ambiguous descriptions of what things are.
Science does a really good job of explaining things within its model. And when I say it does a really good job, I mean the good job has to be judged in the only context that it can be judged. Does it make accurate predictions? And science, in the case of things like what happens in the solar system, it makes incredibly accurate predictions, 10-digit accuracy kinds of predictions.
Okay,
if you want more than that, I can't help you.
Sure. Maybe it's made a few descriptions. I'm going to let you go, Arul, after this.
One more question.
Yeah, real quick though. So yeah, sure. They've described some things. They made some predictions, but I don't think science is really actually explained as much as you think it has. It's never explained what energy is. It's never explained magnetism. It's never explained a field. I mean, it's just only touched on like vague, ambiguous descriptions of these things. And these are the things that are like intrinsic with all phenomena. And it's just kind of like discerning to me that, you know, these things that are intrinsic with all phenomena, they just, for some reason, can't put a finger on it as well as they should.
Sorry, I just couldn't disagree more. You talk about making we haven't figured out magnetism. So we have exquisitely precise understanding of how magnetism works, in the sense that we have these models that make accurate predictions about what happens. You set up anything you want. I can get my pencil and paper out and do some mathematical calculations, and I can tell you what will happen in reality.
That's the problem.
You can't ask for more than that.
That's the problem, John, is the fact that you're asserting math in lieu of explanation and acting as if your quantification and prediction models is an actual explanation, and it's certainly not. Math has never explained anything, and it never will, because that's not the purpose of math. It's a descriptor. It's not an explainer. Okay.
Well, if you want,
I'm going to let Arul go. I'm just going to let Arul go. You could respond to me, and then I'm going to let Arul go.
Okay. No, I mean, I'm just going to say, if you want a better explanation than the explanation that is in our model, here's what magnetism is: spinning electrons lining up. And I can tell you in as much detail as you want, but I'm not going to lie to you and tell you that is what reality is. It might be, but I can guarantee you that you're never going to get a better explanation than that from science. If you want, I'm not sure what it is that you're looking for in an explanation, but if you want more than that, you're going to have to look outside science.
I got
maybe we can finish the conversation another time in regards to the magnetism, electricity, light, energy, these things, fields, things that science has never actually explained. Go ahead, Arul.
I just got one question. One question for John, which I think it's going to be illuminating for a lot of people with regards to relativity. So in special relativity, John, is there an objective present moment, aka an objective now?
No.
I just want everyone who is a globe earther to just let that sink in for 1 second.
What was it again? Can you repeat it?
I asked him, is there an objective present moment, meaning now? Is that an objective thing?
And I said no immediately because of the word objective. There's a subjective moment, but there's certainly no objective moment.
Okay, I just want all the globe earther to just hear that from the mouth of a PhD. That's why I asked the question.
It sounds like he's denying time.
Yeah, they time. That's why.
That I'm not denying.
No,
Time is in the theory, time is a thing, right? And I think personally, I think time really is a thing, but I don't know.
let me just bring it back. And so remember earlier on when I said when they refer to time,
There would be no progression
Why are you interrupting me, brother?
of
Yeah,
events through
left
our
lane.
reality if there weren't any time.
Left lane, you can go right after Rule, dude. He was right in the middle. He was leading up to something.
So the reason I asked that question is because remember in the beginning, right at the beginning, if anyone listened to me, when I said that the concepts of motion, time, and space in relativity, both general and special, do not mean what we think they mean in actual reality. In their world, these are nondescript things which have math, they're just based, they're not actually the things that we are referring to. They're just like mathematical representations of something, but not the concepts that we are thinking of in our minds, which is leading to, sorry, I called you Jeremy earlier, I got confused, but what you said, Dicelo, about the antipodal globe not growing, yet accelerating either side. That's because they're not referring to the space and time and motion that we're thinking of.
They're perceiving it in reference frames. So, I mean, antipodal's kind of out of the question because that would be a whole separate reference frame, and that's when it falls short. So, I mean, it shows very well the ridiculousness of assuming that the ground could be rising in any reference frame. And this is the problem, is like when you base everything off a theoretical model, right, and you leave off with vague descriptions of what things are and what's actually happening, then you lose sight of doing science. You're no longer doing science anymore. What you're doing is mathematics. That's what you're doing.
Well, I couldn't disagree more, but I'll just leave it at that.
Yeah,
Well, in order
that
to
ain't right.
explain, you have to explain the things that we're talking about. In order to invoke
Well, what is
time
it you want me to
space,
explain?
in
Give
order
me
to
one
invoke
thing.
time and space and to give physicality to things that are non-physical, one being a privation, the other being a convention, and expect to have the listener accept the fact that you're invoking physicality onto things that are non-physical, it's absurd. It's ridiculous and preposterous.
Well, just ask me to predict anything. Ask me to give you a fact about where the sun is at any time. Anything you want, and
Yes.
I'll tell you in terms that you will
agree.
completely understand.
I agree. You can predict it all because you guys are glorified mathematicians seeking to quantify and quantize all phenomena into discrete particle interactions rather than actually getting into a precise, logical,
What's
rational
wrong with
explanation.
that?
No, wait a minute. That's like an elaborate misrepresentation of what we're talking about. We can't even figure out that to you falling towards the earth, the ground, you see the ground coming at you. That's all it is. It's nothing to do with the globe getting bigger or growing in diameter. It's just from your reference frame. If you're falling, it looks like the ground is coming at you. It's reference frame dependent in how you describe the motion. That's all there is to it. There's no more to it than that.
I agree.
All right.
I agree with that.
Well,
And I do
what's the
too.
problem
I
is?
agree with that too.
Well, the problem is we're talking about logical, rational reality, like explaining what's actually taking place, not just using these vague, ambiguous descriptions to shoehorn your model into, showcasing how predictable it is. Like, that's not doing science.
Well, I
Not
don't know
doing
what
shit.
you mean by vague predictions. Ask me any specific thing, and I will tell you very specifically what the distance is, anything you want. I will tell you in nothing but terms that you completely understand. There's nothing that's outside the realm of science other than, you know, what is reality really like?
That's a
Because
bold
we can't,
statement.
we don't know. We
That's a
don't
bold
I have
know.
a
statement
question when y'all get.
for actually
I want to go
admitting that
next.
you can't define what space is actually. You can define it only within the
But
parameters of the
I don't
model.
even
So when I
know.
ask you, what are these things? Define these things with
I can
a logical explanation. And I could list off the names of things, and you're not going to be able to do it. And that's a
Yeah,
problem.
I can do it within my models. With this, we have models, we have theories, and those theories include things like space-time, like space and time, if you're in Newtonian physics, mass, weight, energy. I can tell you what all those things are within the theory,
I
but I just
understand.
don't know what they are in reality, and neither do you, and you never will.
Well,
You can't know
that's a
what
bold
reality is.
that's
You
a
can
bold
only
statement.
know what it does.
That's a bold statement to say that you can only give it to me in such a way, right, that might not comport with reality, but it certainly fits within the model.
No, I
And
didn't.
then
It
hold
has to
on,
comport with
John, come on,
reality.
dude, John, come on, and then go on to tell me that I can't do it. So because you failed within your model, now you're going to project onto me what I can't define because you came short. Like that's not fair. That's not fair at all.
If anything I ever tell you does not comport fully with reality, comport fully with reality, then the model that I'm using, the theory that I'm using, is wrong.
And you've already showed that. When I asked
We
you
agree
about
with that.
space, I asked you about space, I asked you about time, and you openly admitted in reality, I couldn't tell you, but within the model, this is how it works. So I mean, it's like you're
Ask
double
me
speaking.
about anything that you can measure, anything that you can actually determine. I can tell you what it will be, and if it doesn't turn out to be that, then the theory that I'm using to tell you that is wrong. Nature gets the last word. Reality
looking
gets
for
the
predictions.
last word.
I'm not looking for predictions. I'm looking for logical, concise answers and explanation as to what things are in reality. And then we're going to go from there and we can science it. But until you can do that, you're confining me to your model, which has been shown to be based on absurd assumptions, like
That's
the bending and
nonsense.
warping
How
of
has it been
space-time.
shown? I'm sorry. Look, how has it been shown to be nonsense when absolutely everything that we predict with it comports with reality? Everything.
You mean
You're like a hammer. You're
Anything
like a hammer
doesn't
saying that
comport with
everything's a nail,
reality,
dude.
then it's wrong.
You're-
Reality gets the last word.
Okay. Well,
It's
anyhow, I
literally,
can't carry on. Go.
You're
Somebody
a
else.
robot.
it's
Like, how
literally,
are you repeating yourself? But I wanted to go next. I had a question. John, when you're using an accelerometer and I'm going up, is it measuring my acceleration in an upward fashion?
An accelerometer always measures your acceleration.
Is that a yes? I'm
I'm not sure maybe I didn't understand your question.
okay. I'm on Earth. The accelerometer is measuring what? What's the reading?
You're standing on
Oh.
Earth,
Yeah.
then the reading on a functioning accelerometer will be 9.8 meters per second upward.
Okay. And now I go upward at the same rate. What does it read? It reads 0?
What? So you mean you're now accelerating upward at that rate with respect to the ground? Is that what
Yeah.
you mean?
The accelerometer in my hand. What's it read now?
I don't know. You haven't told me what you're doing. Are you just moving up at constant
I did tell you,
velocity?
just didn't listen. I'm going up at the same rate.
Twice or is he twice? The answer's twice.
Why can't John understand it? I don't get it.
Well, I don't know if he's talking about going up at some velocity or going up relative to the ground at some acceleration.
At the same 9 point. Never mind, dude.
Well, if you're accelerating, if you're in a rocket ship that's accelerating upward relative to the ground at 9.8 meters per second squared, then your accelerometer will read 19.6 meters per second squared, as whoever that was said.
Okay, yeah. You know what's interesting? You said something interesting. You said it's not nonsense, right? So therefore it must make sense, right? You're saying it must make sense. So when we use our senses, our physical senses, what physical sense are you using that it's self-evident to you that the earth is a globe?
Well, for me, so one thing, of course, is I haven't done this myself, but I have a friend who rode on the space shuttle 3 times. His sense is the sense of vision. He looked out and he saw the curvature of the Earth.
Okay, yeah, I specifically wanted it to be
So for me
you.
personally, I don't know that
Yeah.
I have any direct other than things like the fact that if I went to the
Okay, so it's nonsensical.
well, I don't know, whatever you want. I mean, I do trust people, right? I trust my friend, for instance,
Yeah,
and
but
he's
how about
seen it
like
with his own
spinning?
eyes.
So how about the spinning of the Earth? Did you see the Earth spinning?
Yeah, the spinning I've seen with my own eyes in the sense that I've watched a Foucault pendulum at a science museum.
And then do you have evidence of a Foucault pendulum not processing, like at the equator?
No. Oh, at the equator, yes.
Okay.
At the equator, it doesn't process.
Oh, you have
That's right.
evidence of that?
Oh, I
You have
don't. I mean,
evidence
I've
of
never
that?
seen one at the equator to know
Oh,
that it doesn't process. No.
because what if pendulums just process is all the Foucault pendulum is showing you?
Well, it would be interesting because the rate of precession depends on your latitude. So it would be a very strange thing if every Foucault pendulum around the world just happens to be precessing at the right rate for its latitude.
Well, the latitude
Yeah.
would be
If you set it up properly and you do it a couple times till you get the result you want, right? Like the
Okay, so
guys
you're
in
saying people
Antarctica
could be
had to
lying
do
to
it
you.
like
Yeah,
3 or
I mean,
4.
if you believe people are lying to you, then all bets are off. That's
They're
right.
you
making
are a
up.
weird dude, bro. Why are you here? I would like to know that. That's a question to you. Why are you here? From that comment alone, bro, that is just strange. He never said that. He never
He's
said
preaching.
anything about lying.
No, I
But
was
what if
hold
the-
on.
It sounded like that's where he was going. I don't know.
Well, right. What I interpreted, I understand why John said that because he might have implied that. I think maybe what Torah was saying though is I'm just trying to steelman it was more the idea that like that a Foucault's pendulum will process depending on how you let it go or whatever. Like and he's just saying that like I think Torah, weren't you more saying that like let's say your latitude was 30 degrees and if it's not a real thing that you could just do it a bunch of times until you get the precession of 30 and then call what it would be at 30 and then call it a day, right? Is that kind of what you were?
Yeah, like setting up the Texas sharpshooter fallacy, essentially.
And also,
So
what if the precession rate has something to do with something else that does depend on latitude? Let's just blurt off something that might be ridiculous, electromagnetism or whatever the field is moving, right? What if the precession rate of something swinging back and forth is affected directionally and precession rate wise due to something like that? Then it would change due to your latitude.
Yeah,
Well,
the
if you're
interesting part about
suggesting
this
that
is according.
you're suggesting that there's some magnetic effect that is precisely determined by your latitude. I don't know of any such thing, but you're free to, of course, subject a Foucault pendulum to magnetic fields, see if that has an effect on the precession rate. I mean, once again, there's a little bit of a
because okay, I'll address that. It seems to because of during different phenomena that the precession rate either goes in a different direction or stops. And the fact that we haven't done it on the equator, I would like to see that. I don't think it would precess on the equator, even if it was due to something like that, because the field is neutralized there as well. That's the center point, right? Like, but
what do you mean? I mean, there's a magnetic field at the equator, and it's not uniform, right? Different places, it has different dip angles at the equator. It has different directions at the equator. It's not.
So it would be interesting. You agree? It would be interesting to do Foucault pendulums at those different places that that there's different, magnetic fields or whatever.
Well, we already have that. I mean, we have hundreds of Foucault pendulum around the globe, and they all precess at the sign theta, the sign of latitude dependence.
That's not what we were talking about. We skipped past that. We went to the equator. So do you know of any on the equator? Because I think that's something like 24-hour sun. Like we're all kind of been asking that for a long time. It'd be neat to see one process or not process.
Well, okay. And is the result going to be the same as the result after we see that there is a 24-hour sun?
I don't know. How would we know until we
That's
did it? It's
not
called
accurate.
falsification. And all the three universities I called when this first came up like 5 years ago said that they dropped the Foucault pendulum out of their curriculum, like requirement thing that they were doing because it's so inaccurate and you just adjust it till it is accurate.
Well, I don't buy that. I'm not buying that. Your assertion that that's true, I'm not buying.
Well,
John,
Here's one thing about
maybe we
setting up
don't
a
understand that.
Foucault. Setting up a Foucault pendulum
get
at the equator is probably something that few science museums would want to do because it would be pretty boring, right? I mean, it would be interesting. You're right. I mean, I'd kind of like to see one just to see that it doesn't precess.
We-
But but it
They
would be
ha-
kind of
they have a
boring for the
lady at the
general
top-
public.
they have a lady at the top of a mountain flushing water down a drain in Ecuador because of this. So yeah,
I
think
know
people
that's
would
a,
want to see it.
that's
But
a
hey, John,
grift.
real quick before we go into that, I just want to say, so you're stating with the theory of relativity, if you put the Earth as the center point, right, and stationary, and the sun revolving around it, you have no explanation for the Foucault pendulum.
No, I mean relativity. Basically, the Foucault. The one thing we do know is that rotation is absolute. When an object is rotating, you can tell that it's rotating, just like acceleration. Acceleration is absolute as well. There are things that will measure rotation rate, laser gyros, etc. There are things that will measure acceleration. There's no such thing for velocity, but there is for rotation and for acceleration.
So from the reference frame of Earth, right, being in the center with the sun going around it, what's the cause of the Foucault pendulum precessing? Because I do have Einstein's, what he said it
Right.
would be.
Yeah, you're probably referring to Mach's principle. Is that where you're going?
Well, he said the distant galaxies, turning would cause that effect on the Earth.
Yeah, Mach said that. Einstein was inspired by Mach, but he ultimately parted with Mach, so he didn't believe that at the end.
So relativity, even though you can treat the two frames as being similar, once you put the Foucault pendulum, you know the actual reality, what's going on. It's definitely not the Earth being stationary, right?
Yeah,
so
well,
you do know something.
Far better than the Foucault pendulum these days are ring laser gyros that are they're using ring laser gyros these days, not just to tell trivially that the Earth is rotating, but to actually monitor changes in the rotation rate. Turns out that ring laser gyros are actually the most sensitive detectors of the Earth's rotation. And they're actually, as I understand it, they're actually detecting things like the melting of the polar ice caps, the kinds of things, the daily changes in rotation rate, which are actually detected by ring laser gyros.
Okay, I'll
Can you
consider
say
that a
one more
concession.
time?
I'll consider that a concession, seeing you're going to move the topic to a different topic. So that way we're conceding on the Foucault pendulum at this point. Because your ring laser gyro taken to higher altitudes, you get the same reading still?
Ring laser gyro just measures its own rotation rate. So if it's on the Earth, it'll measure. If it's fixed to the Earth, it'll measure the Earth's rotation rate.
Yep, and so if you take it to the top of Mount Everest, you're going to get 15 degrees per hour?
Temperature is temperature sensitive.
Well, there may be some instrumental things like that. I don't know. I don't think there are, but there might be.
So it was interesting that you don't know what reality is doing, but when it comes to the case of the Foucault pendulum, we can be confident the Earth is spinning because now we know all of a sudden what reality is doing.
Well, that's a fair enough comment, right? When I say it's rotating, I mean that the thing we all agree is rotation is that thing. Now, maybe in reality, rotation is some other thing. Maybe it's not even three-dimensional space. Who knows? But I think we all, I haven't taken so much leave of everyday language that I don't use rotation in the way we all do.
What would be one of the cause of a ring laser or a pendulum to precess if the Earth was stationary? Just hypothetically, you're smart enough to have probably thought about this.
What would cause a Foucault pendulum to precess with a precession rate that depends on its latitude on Earth if the Earth weren't rotating? Is that what
Process
you're
it all.
asking?
You can use latitude. You can do whatever. Process it all. What would cause it? Let's say you didn't know the latitudes made it a process at a different rate, but what you did know is when you swung back and forth something on a pendulum, it processed at a certain rate. What would you like? Not knowing if the Earth was rotating or not, what would you kind of think of and put on the list of causes?
I'm not sure I understand exactly. I mean, I don't know how I'm supposed to answer that question. There are other things, of course. You could have a mount. You could have a mount that caused the Foucault pendulum to precess. And yes, and I know, of course, immediately, I'll just say it. Of course, you could, if there was a massive conspiracy, you could set up Foucault pendulums in science museums around the world with devices that just made them precess at